So at this point you have already learned quite a few things about functions. And in this video what we will talk about is that you can actually also do operations with functions. So you can add two different functions, can subtract them, can multiply them, and you can divide them. Now how does that work? We are basically taking each function value and doing the operations on that. So the official definitions are shown right here. I'm going to start with addition. So if we add two functions, that means at every point x of the domain of the function, we are simply adding the function value of f and g. That's it. And then we do the same with subtraction. We are simply subtracting the two function values at every x of the domain. And then the same for multiplication and for division as well. To illustrate that, we will actually use the following example to show how that actually looks in action. I made one mistake here in the instructions, so we'll be taking those two functions f and g, and we will add them, we will multiply them, and we will divide them. After working each example, we will then also state the domain of each of those functions then. So let's get started with addition. So we have our function f of x and g of x, and we want to add them. So we write f plus g of x, and I highly recommend that you always start with the definition of what that means to add two functions, because it makes then the subsequent steps fairly straightforward. So we're writing out again that this is f of x plus g of x. So what do? Well, we now just fill in our f of x and g of x. So we have here 5 over x minus 1, and then plus our g of x, which is 1 over x plus 6. So this is a little review in how to add rational expressions, and we need to make a common denominator. The common denominator here is x minus 1 times x plus 6, and so therefore what we do is we multiply our first fraction by x plus 6 over x plus 6 in order to make our common denominator, and then for our second fraction we take the opposite. We take the multiplied by x minus 1 over x minus 1. So we have here 1 over x plus 6, and then times x minus 1 over x minus 1. So now we can write everything on one denominator. So we get 5 times x plus 6 plus 1 times, I'm going to write that out once, 1 times x minus 1. And then our denominator will be x minus 1 times x plus 6. And then I distribute the numerator to get 5x plus 6 plus x minus 1. While the denominator we usually just keep in factored form. That has several advantages that we actually will cover at the end, more towards the end of our class. And then the last step is to simplify the numerator to get 6x plus 5, and then we again have our denominator as is. So then the domain for this new function will be, right, we have a denominator that should not be 1 and should not be negative 6. So our domain therefore will be all x's that are not negative 6 and are not 1, because those two numbers will make the denominator 0, and that is not allowed. And then if I want to write that in interval notation, it will look like this. Negative infinity to negative 6 not included, right? Because negative 6 is what we are excluding, and so then I in union with, or I combine that with negative 6 to 1, again both negative 6 and 1 excluded, and then in union with from 1 all the way to infinity. Means all the numbers except the two exclusions of negative 6 and 1. So that is our new function f plus g of x. And if we did subtraction as well, the one thing we would have to watch out for, so everything would be pretty much the same, we would have to watch out for at this step here that we then would have a minus 1 times x minus 1, and we would have to distribute the negative 1, getting negative x plus 1. Other than that is exactly the same steps. The other thing at other times we will have to consider is at this step we might not be all the way done yet. So sometimes the numerator can then be factored again, and then you can still cross something out. That means you can still cancel something with the denominator. However, it is always important to remember that when we find our domain, both here and here, then we always need to take into account our original functions when we started. And already here at this point we can see that x must not be 1 and x must not be negative 6, and then even if something cancels at the end, we still have to keep that in mind, that the domain excludes those two numbers. Now next we will multiply our two functions, and we will again start with our definition of what that means. So f times g of x equals just simply multiplying both our function values f of x times g of x, and we take our two functions again and then multiply them. So we have 5 over x minus 1 times 1 over x plus 6. So multiplication of fractions is a lot quicker. We just multiply the numerators and we multiply the denominators, and we get 5 over x minus 1 times x plus 6. And again we just leave our denominator in factored form, and sometimes if you have a more complicated numerator you might be able to factor something out again that then lets you cancel with the denominator. But at this point that is all there is, and we will again look at what our domain is, and it turns out again we have to take into account that x cannot be 1 and x cannot be negative 6, and we're writing it again in both set builder notation form as well as interval notation. Now our last example is when we divide our two functions, and we again start same thing. So I highly recommend when you work your homework that you do the same thing, that you always start with the definition of what it means to do any of the operations. So in this case divide, by simply writing it out as your first step. So we have f of x divided by g of x. And again we are now filling in our two functions, and we will be getting a complex fraction here. 5 over x minus 1 divided by 1 over x plus 6. Now I always find it very helpful to really keep track where's my main division line. So that in this case is this one, and I always make it a little longer, helps me keep the overview, and then my fraction in the numerator and my fraction in the denominator I make a little smaller, so I have clearly know where I need to go next. And division is defined as multiplying the reciprocal, so that will be our next step. We will multiply by x plus 6 over 1. So here we go. So I have 5 over x minus 1, and then times x plus 6 over 1. So now I'm back to multiplication, and I can simply write that equals 5 times x plus 6, and my denominator now is only x minus 1. And depending on the situation, we may or may not distribute the numerator. That depends on a few factors. One of them is whether or not you can cancel with the denominator, and sometimes it's just simply a matter of style. So what about our domain here now? The x plus 6 has disappeared out of the denominator, so it's tempting to think that, oh, my x cannot be 1. However, in math we always honor the history of the problem we are working with, and the history is that we started off with a denominator of x minus 1 over here, and then also a denominator of x plus 6. And even though then at the end, because we're multiplying now by x plus 6, the x plus 6 disappears out of the denominator, we are still honoring that that was a denominator once, and therefore our domain still remains the same way, so that x cannot be negative 6 and it cannot be 1. However, I cannot see that anymore when I have my final answer here, and because of that I need to actually write that in explicitly, that x at this point must not be negative 6. So I'll write that in my final answer, and technically we should already be writing that over here, because already at this point we cannot see anymore that x must not be negative 6, and so we're always writing that. So because we can still see that x must not be 1, because it's still in the, x minus 1 is still in the denominator, but we can no longer see that x must not be negative 6. But since that is the case, we then explicitly write that right next to the problem. So now you have an example of what that actually looks like when we add, multiply, and divide two functions, and what it does to the domains of the functions.